talk about the project requirements and goals. Most of them were consisting of overcoming the bridge between real and digital world, maintaining accessibility, and getting system as robust and secure as possible. Then I will talk about possible applications for such a project, and followed by a video presentation of my work done so far on similar case. At the end, future work and your questions. Straight on, GUI. GUI is basically user interface with graphical features, mostly referred to as WIMP, which stands for Window Icon Menu Pointer. To make it more clear, let's take a look at the example. We have a window with menu, then we have button and labels, which are basically icons, and pointer, mouse pointer, which is pointer. Graphical features need to have three main points to satisfy the criteria. These are functionality, of course. They have to be appealing to the user and self-explanatory, so they do not need any additional explanation. For example, everybody knows floppy disk. This is basically a save button which saves all the work done so far. It is an example of great graphical feature. I mentioned that there is one of the requirements which is basically trying to overcome bridge between the real and digital world. And let us take a look at first to physical wind tunnel. Like already mentioned by Jakub, there are many different types of wind tunnels, but mostly all of them have the same simulation process, which is basically creating a model, real model, inserting it into the fan duct and firmly attaching it to the sensors, recreating desired flow conditions, running the simulation, obtaining results, evaluating and repeating if necessary. However, in digital world, it is not the case. There are some things that we have to, some stages we have to do before obtaining results. In general, simulation process in digital world is divided in 3 stages. This is pre-processing, processing, and post-processing. To break it down a bit, in pre-processing stage, we have 3D modeling. The model is created using any of the commercial or open source softwares. The model is then used in the meshing stage to translate the continuous space to discretize the continuous space. Then mesh is obtained and used in the solving stage, processing stage, where solvers solve algebraic equations using with the help of numerical methods, taking into account boundary conditions, initial conditions, and flow properties. These results are then used in the post-processing stage, where we can visualize them, evaluate, and of course decide to repeat if necessary. I'm not going to go into details about all these stages. It is important to notice that user interacts with all of these stages. This means that GUI has to be designed in such a way that it allows user to interact with all these stages, to see the results and to decide what to do next. To create substantial GUI, one has to know exactly what kind of software is behind the scene to operate with it. Therefore, a brief study of softwares was taken, and this led me to OpenFOAM. Let me talk quickly about OpenFOAM. OpenFOAM is open source field operation and manipulation. It is CLI driven, which means it has no graphical user interface, because it is performance oriented. It has many utilities implemented. One can calculate stress. We can calculate chemical reactions and perform simulation. In this particular case, we have motorbike test case pressure field, which is obtained by using incompressible solver. And on the right, we have Snappy Hex Mesh utility, which is used for automated meshing. choosing OpenFOAM as a software workhorse, if I can say so, gives us huge flexibility because it is written in C++. It is open source. It can be easily manipulated, new utilities easily implemented or even changed. Therefore, future work is not so limited, and many different things can be added. One of the requirements was as well making the GUI as much accessible as possible, and we cannot make it more accessible than putting it on World Wide Web. Therefore, I had to get myself introduced with HTML, CSS, JavaScript, and PHP. To break it down a bit, let me give you an example. HTML is hypertext markup language. It is basically language used for structuring web pages, giving them content. In the example, we can see it's not such of a great look, which does not satisfy criteria that graphical user interface has to be user appealing, if I can say so. Therefore, CSS was introduced. These are cascade style sheets. We can see that the result is much more appealing, but we do not have any interaction implemented. Therefore, JavaScript language is used to implement any kind of user interaction, possible user interactions on the web page. Here, for example, we can see cylinder case being colored according to the pressure array, which is obtained by OpenFOAM solver. The next requirement was robustness, security, and choosing appropriate web architecture gives you both. Why is that the case? If we take a look at the right figure, we can see the three-tiered pattern and the MVC design model, both combined, and user interacts and sees only the view layer. And the database itself resides on the far right, which means that user and database are completely separated. Therefore, this gives security, robustness, and this prevents any kind of SQL injections to accessing database directly. And to work with this particular database data model framework, I had to choose appropriate IDE. This led me to Visual Studio Community Edition with latest framework, because only latest framework supports the best framework model. Going straight to applications for this GUI, but let us take a look at first about advantages itself. We have web application, which means it's accessible from anywhere. It has GUI, this means it's user friendly and suitable for everyone, of course with a certain level of knowledge. And the OpenFOAM is used as a software background, and this means it's suitable for a variety of computationally demanding cases. In this particular case, on the left figure, we can see that we've obtained aerodynamic properties of the entire aircraft, or on the right, again, motorbike test case, obtaining pressure field. To break it down a bit further, so far I have managed to implement these things, these bullet points. So far, we can obtain residuals and decide if simulation has converged or not. We can obtain drag and lift coefficient of any model inside the fluid domain. We can set custom provocation and obtain values of these locations. We can select our own planar or existing surface cuts, or even extract the entire surfaces and evaluate results. All this will be shown in the video later. Well, actually, the video that I'm promising is right here. First, user navigates to the web page, and if he wants to access any of the tabs, he has to log in first. Security Then accessing his private workbench gives him possibility to create new case. And this is simply done by putting the name, in this case Ali, setting the appropriate units at which model was modeled, selecting case, selecting model, and uploading. When this is done, to check if the appropriate model was uploaded, we can visualize it using view existing model. In our case, we are going to take a look at cylinder. So let us take a look at cylinder. When we are satisfied with the model we uploaded, proceeding to meshing workbench, where we can input our custom parameters for meshing. These are done mainly on the basis of SnappyHack's mesh utility mentioned earlier. In this case, we are going to introduce one more layer, saving parameters, and then submitting mesh to the meshing stage. Here we can check if our layer has been saved. It has been saved. And when mesh is when the mesh is obtained, model discretized, we can see the results in the existing mesh. This is mesh obtained actually not by SnappyHack's mesh because I ran out of time. But I can say thanks to COD students that helped me out with the case and providing me with the mesh. If we are satisfied with the mesh, we can set flow conditions like pressure, temperature, flow speed. New things can be implemented. In this case, we are going to set probe location, which is for obtaining values in point in space. We run the simulation, and when simulation is obtained, when results are obtained, we can visualize results. There are many ways we can see results. There are 1D, 2D, and 3-dimensional ways of viewing results. In this case, we are taking a look at the plot of provocations, coefficients of lift and drag over the time. Then we can take a look at sectional plots displaying pressure in the plane, the one that you've seen before. We can change the color according to if it's not visible enough. And then, like promised, we can see also 3D models which are colored according to what we select, so velocity, pressure. And when the user is happy with the results or not happy, you can also delete the case. Process is completely irreversible, so pay attention. And then logging up to conclude the simulation case. The last thing that I have to talk about is future work. There are a lot of things that have to be done. A lot of things have been done, but there are still many left. For example, database work. I have to work on implementation of more effective delete method. I have to implement spatial data type because so far all the points, all the geometry locations are each geometry location has 3 integers. Spatial data type allows storage of all 3 integers in one type. I have to improve data results handling, and of course obtaining forgotten passwords for the users. This is important because the user forgets the password, of course, and he wants to see the results. He can't without the password. Okay, that would be all. I hope it's not as boring as the title was. So if you have any questions, please feel free to ask.
Any questions? Do you know all the acronyms? I have a question for you. So you said you chose OpenFOAM.
Why?
Well, over what? Did you try anything else, or did you?
Yeah, I tried, for example, Salome for meshing, then NetGrid for meshing as well. Then this is the part for the meshing that I tried. Then I've tried star CSM plus, which is for solving. Fluent for solving. I also tried some commercial codes for solving. Well, just overview, not basically tried. But at the end, I got to the point that OpenFOAM offers everything. Of course, it is. It's not the meshing stage itself. It's not so efficient. It's not better than using it on your own manually. But automated process of meshing can be so adjusted that there are some companies basically using only automated meshing without manual meshing. I mean, non-manual meshing. So this got me to the point that OpenFOAM is easily manipulated, and a lot of new things can be implemented. So that's why I chose it. And it's written in C++, which was beneficial for me because I had experience with I knew the other language.
So the thing with OpenFOAM, it's not just open source, it's developed by users.
Yes.
Yeah. So how confident are you with the validation of all the bits and pieces that are put together?
I was well, I was not validating myself, but I checked validation that users made, and I was surprised by validation comparison between OpenFOAM and ANSYS Fluent. And I cannot provide academic response to this question, but I can say that there was barely a difference visible from their report has been made just to compare the result. But I mean, there are other companies that are using this. It's getting used more and more. Also, research center in Germany. So I suppose that it is good enough to make GUI based on something, but this GUI can be translated to any kind of software as long as the developer knows the software.